Assalamualaikum and good evening. In this video presentation, me and my colleague will be discussing about the parallel processing and assembly station simulation. This mini project is a requirement to complete the core subject Computer-Aided Production Management that is led by Mr. Muhammad Ma'aruf B. Baharudin. In general terms, it's about studies of using computer software to create a 3D simulation used for modeling and analyzing manufacturing process, particularly in the context of digital manufacturing. In this mini project, we are assigned to create a simulation scenario and conduct an in-depth analysis based on parallel processing and assembly station using the Mia Quest software. Here are the reference layout plan used for processing and assembly for the project simulation. There are several main components used in this layout. There are three main sources that are used to create raw materials to be processed into each respective parts. The raw materials are put into each respective buffer A1, B1, and D1 before entering processing machine. After the raw material has been processed, which is part A, B, and D, they will be put into respective buffer before transported into the assembly buffer. The parts in the buffer assembly will be used in the machine assembly to be assembled as part C. The completed part will be sent to the cool down buffer before storing the part in the sink. Each machine and buffer has an operator assigned for processing, assembly, and transporting parts. Here are the simulation requirements for the parallel processing and assembly station simulation that are stated in the mini project instruction. 3 parts from 3 sources A, B, and D with 90, 120 seconds respectively, excluded part C as passive. Machine 1 has a total output of 3, Machine B has a total output of 4, and Machine D has a total output of 4 parts. Machine assembly has a cycle time of 150 seconds with the combining part A, B, and D to make part C. All machine has a constant logic processing. In the end, assembly part C need to be cooled down for 10 minutes before entering the sink. Each operator has assigned to handle the process of respective parts. Ops 1 for part A, Ops 2 for part B, Ops 5 for part D, Ops 3 for handling part A, B, and D, and Ops 4 for assembling into part C. All operators have constant speed of 1.2 milliseconds. In the simulation, daily plans are implemented to simulate the real working environment of manufacturing line and worker. The work shift runs for 9 hours per day, including 3 breaks, morning, lunch, and afternoon, only apply for workers and buffer. Machine breakdowns are a common occurrence in manufacturing line. To implement the breakdown in the simulation, all machine has the NTBF of exponential 3000 seconds using busy time, and MTTR of uniform from 180 to 300 seconds.
So now we move on to the result analysis slide. So from here we can see that machine A theoretical cycle time was actually at 90 seconds, but the actual was slightly faster, which is 79.2 seconds, resulting in slightly higher production rate, which is 45.45 frames per hour, rather the same like the 2021. So the machine B actual cycle time was slightly lower than the expected value, which is only 85 seconds from 86.4 seconds, with a production rate close to the theoretical value. Next, we also can see that the machine D with an actual cycle time of 93.6 seconds and a production rate of 38.46 units per hour, which is very close to the expected 37.89 units per hour. However, we can see here that the assembly machine showed the most significant difference because the actual cycle time was 151.2 seconds compared to the theoretical one, which is 165 seconds, which means that actually it's kind of perform faster than the expected one. So from this also we show you the graph to show the difference between the theoretical and also the actual value of the cycle time and the production rate. So from here we can see that the production rate actually increased from the projected 21.82 units per hour to 23.81 units per hour for the production rate. Okay, now we move on to the labor utilization slide. So as we can see from the chart here, it's shown the utilization chart for the operator. So from here actually we can see the significant difference in the chart, which is operator 3 has the highest utilization rate, which is at 21%, making them the busiest operator. This is actually because operator 3 is responsible to handle the transporting parts from machine A, B and also D to the assembly station. In comparison, we can see here the operator 4 who operates the assembly station only shows a 1% utilization rate, meaning that they will idle most of the time. Okay, so the summary for each operator's role is operator 1 will handle and transport part A to machine A, while operator 2 handles and transport part B to machine B. Same goes to operator 4, which is operator 5, which is handle and operate machine D, while the operator 3 will transport the parts A, B and D from output buffer to assembly, and the last one is operator 4 to operate the assembly station. So we also can identify the patterns for the idle time, which is operator 4 has idle time for 7.816 hours out of 9 hours, which is too high. And operator 5 idle time is 7.192 hours, while the operator 1 and 2 idle more than 6.9 hours. So to improve this, we recommend to redistribute some of the operator 3 tasks, which is assign a helper or using automated tools like conveyors to reduce the travel time and spread the workload. Okay, now we move on to the final production output slide. As we can see here, this is a summary one, which is the finished part is 149 units. So the suggestion to improve the overall production is the cycle time at the assembly station should be reduced. This can be done by adding some automation like conveyor or giving support to the operator 3 during the assembly process. Since this station is the slowest and limits the whole system, making it faster will help to increase the total number of products made. Alright, so for the conclusion, the knowledge gained from this project is actually the increased IAP and optimized load size allow for a smoother and unified flow of components. And also the increased working hours and double production rates improve the process of reliability and also reduce the delays. The knowledge gained from this course is the challenge from the original production line that can result in efficient production process, and also to how to familiarize the production process in the working environment. So for the critic extension for the